Hello, everyone. I hope each and every one of you is doing great. Yes, we are back again to our math journey. And if you haven't subscribed yet, please do us a favor by subscribing to our channel, Tutoring Made Easy. Please like the video and share it to as many people as possible. Last time when we met, we discussed a topic called indices. We looked at indices and we said that indices was propounded. It was propounded by a man by name Samuel Jeek or Jake. I think I don't know whether I'm pronouncing it right, but Samuel Jake or Jeek in the year 1696. In the year 1696, and we went straight ahead to say that indices are usually of the form. They are usually of the form like this, something like this, where we said that this part, the A, usually represents what we call a base, and then the N represents something we call an exponent or a power or an index. Yes, that's what we agreed on the other time. So we're going to continue. We are going to continue from where we left off. We're going to continue from where we left off, and we looked at the laws and properties of indices. The first law we said was first law we said that if you have an indices in the form a to the power of 0, it is always equal to 1. And we looked at an example and we said that if you have two whole number to the power of 0, it will give you 1. If it's a million to the power of 0, we'll get 1. All right. With the second law, we said that if you have a exponent m, and you are multiplying that by another m exponent n, we said that it is a to the power m plus n. That's what we agreed on the other time. And we are saying that it is so because we have the bases to be equal. This base and that base is equal, and the product, the sign in there is multiplication. So we add the exponents. Now, the third law, we said that if you have something of the form a to the power of m divided by a to the power of n, whether it's in fraction form, we said it's equivalent to writing it as a to the power of m divided by a to the power of n. That's what we agreed on. And we said that it's the same rule. It is the same as a to the power of m minus n. We're saying that if if the bases are the same, and then the mathematical operator is division, then we have to subtract their index. If you are multiplying, you add their index. So if we look at an example, and let's say you have two whole number to the power of -5 multiplying 2 to the power of 6, because you are multiplying and the bases are the same, we are going to add the exponent. So it's going to be 2 whole number -5 plus 6, which gives us 2 to the power 1. And it's 2 to the power 1 because you are owing someone $5. The plus 6 means that you have it in your wallet, and you are giving your wallet money to the person you are owing the 5. The person still needs to give you a change of 1. That's why this 1 here is positive, and that gives us 2. Now, if we also look at here, we have, let's say, 2 whole number -5 divided by 2 to the power 6. This can be rewritten as 2 to the power -5 divided by 2 to the power 6. And we said that the rule is to subtract the exponents. So that's 2 whole number -5 minus 6, and that gives us 2 to the power -11. That's where we got to the other time. Today we are going to continue with some of the rules of indices. Some of the rules of indices. So the fourth rule, which I'm going to get there, we're going to get there quickly. We're shortly going to get there. Let me clean this board quickly, and then we jump right in. So we're saying that the fourth rule says that if you have a We have a to the exponent of n, and there's also another exponent multiplying the a exponent m and m all together. We say that is the same as, it's equivalent to a multiplying the exponents together, n times m, and that gives us a to the power mn, or a to the power nm. It's the same thing. So an example of such a problem is where you have something like, let's say, you have something like, let's say, 2, you have something like, let's say, 2 to the power of 5 into parentheses, you have, let's say, 2 like this. What it means is that we're going to multiply the exponents together. It's going to give us 2. The n for Nancy there is 5, and the m for mango there is 2. So we're going to multiply them together. We're going to multiply them together, and then we are going to get 2 whole number, 5 times 2, which is 10. 2 to the power of 10, like that. So that's the fourth law. If you have a base with an exponent, and that base with the exponent all to the power of another exponent, we multiply the exponents together. Now, the next thing we're going to look at is if we have a divided by b, and then it's all to the exponent of n, we are saying that, remember, the a there is different from the b. The a here is different from the b. So what we're going to do is that it's going to be a to the power of n divided by the b to the power of n. A to the power of n divided by b to the power of n. Yes, a to the power of n divided by b to the power of n. So that's the rule. Now let's look at an example. An example is if you have 2 divided by 5 in fraction form, all to the power of, let's say, 3. Basically, the rule says that take the numerator, we take the numerator, which is 2, and put the exponent 3 there, and divide it by the denominator, which is 5, with the exponent 3 there. So you're going to get 8 divided by 5 times 5 times 5. Okay, so let me take my time. This one here is going to be 2 times 2 times 2. And we're going to get these two. These 2 gives us 4. And then we're going to multiply this by 2. Divided by these 2 will give us 25. And then we multiply by the other 5. And we're going to get 8. 4 times 2 is 8. Divided by 5 times 25. 5 times 5 is 25. And 25, we always write the number on the right, which is 5. And then there's the remainder. It remains 2. Now 5 times this 2 is 10. 10 plus the remaining 2 is 12. So there we have it right there. So that's the fifth rule. That's the fifth rule. Let's look at the sixth one. Let's look at the sixth rule. Let me wipe this quickly. Let's look at the sixth rule. The sixth rule says that the sixth rule says if you have a to the exponent of negative n, it's the same as writing 1 divided by a to the power of n. Basically making this positive in the denominator. Make it positive in the denominator by putting 1 on the numerator. So if you have something like 5 to the power negative 2, right? What we're going to do in the denominator, we're going to write 5 to the power of 2. We make it like we eliminate this negative sign there. We have 5 exponent 2, and then we put 1 at the numerator. And that gives us 1 divided by 25. 1 divided by 25, right there. 1 divided by 25. Now the seventh rule says that if you have a divided by b exponent negative n. We said that the rule says that you take you reciprocate it. You have the denominator come up divided by the numerator down there. The numerator comes to the denominator, and you change it. We reciprocate it, and then we make the exponent a positive one. So we just have to turn. Basically, what happens is that we rotate the b up, and then we put the b up there and put the a down here, and that's what we have done here. And then this one becomes positive. That's what we're going to do. And then from here, we apply the what? I think we're going to apply the fifth rule. Remember the fifth rule. The fifth rule says that if you have a divided by b to the power of n, it is the numerator to the power of n divided by the denominator to the power of n. And that's where we are now. So here, we're going to have it's equal to b, the numerator to the power of n, divided by the denominator to the power of n. And then that's the seventh rule. Now we're going to do the last one, the eighth rule. It says that if you have the nth root of a, if you have the nth root of a, it is always a to the exponent of 1 divided by whatever is here, which is n. So if you have something like this, if we have the fifth root of 4, what it means is that we will write the fifth root of 5. Let's put it this way. Let's make the fifth root of 6, actually. The fifth root of 6, we're going to write a 6, which is the a, and then at the exponent, we have the numerator being 1 divided by the number that is here. Always you're going to have 1 divided by the number that is here. Always 1 divided by the number that is here. And then there we have it. I hope this helped. I hope this helped. We'll come again. I'll come to you another time, and we'll continue. If you haven't subscribed, please do us a favor by subscribing to our channel, Tutoring Made Easy. And the goal is to make math enjoyable. The goal is to make math enjoyable. Like this video, share it to as many people as possible. I'll come to you another time. Please take care. Bye.